Hi everyone, thank you for coming. This talk is called Advantages of 2D Tile Maps for Mobile. So the intended audience of this talk is anyone who's new to tile maps or new to 2D in general, and you'd like to learn more about some mobile best practices. Or maybe you're an artist or a developer and you just want to become more performance focused. My name is Sophia Clarke. I'm a software engineer at the release QA in the Unity Brighton office. The release team in general are responsible for alphas, betas, patches within Unity. But in my spare time, I enjoy making my own Unity games, and 2D is a platform that I usually make my games in. And within QA in Unity, I work on a lot of different things, so I wear a lot of different hats. So in this talk today, we'll be covering, we've got some bullet points up on the slides. I'm going to do an overview of tile maps, just for anyone who's unfamiliar with tile maps, haven't used them before. I'll be doing a demo to just get everyone on the same page. I'm going to talk about optimizing for mobile and why you should even care about it. Advantages of using tile maps over traditional sprites. So maybe you've used a tile map solution in the past, or you've faked it by placing lots of sprites on a scene, or maybe you've not done anything. But I'm going to compare the workflow and the performance. So I'm just going to talk about tile maps and explain what they are, and hopefully everyone will be on the same page about tile maps. The tile map feature is encompassed of a lot of different things. It's the tiles, the brushes, the grid, and the palette. You can quickly create 2D levels using tiles and a grid overlay, and you can paint that directly onto your scene. On the slide, you'll be able to see like the different versions that the different types are available in, but Square is available from 17.2 onwards, and the 2D team have been making improvements and new features since then. And as of 18.3, you'll be able to use the 3 different kinds of tile maps: square, hexagonal, and isometric. This is the tile palette window. In this GIF, I'm clicking through some of the different palettes I have available. You can paint with one tile at a time, or you can use multiple different tiles. I'm not a painter myself, like in the physical medium, but it seems like it would be really efficient if you were to have all of your different palettes with different color schemes set out and laid out in front of you, and then just pick up the palette you want, right, for whatever painting or mood you want to paint in. So that's kind of what I'm doing here. I'm clicking through the different styles of tiles I have available to me so I can select what I'd like to paint with. In this GIF, I'm using 9 tiles as one brush and quickly drawing out a platform. The 2D tile maps have an extensive API, and you can use that API to create custom brushes or whichever other tools you'd like to accompany your tile maps. In this, I'm using the rule tile. I won't be talking in detail about rule tiles today, but in the link at the bottom of this slide, you can go to the repo and download the rule tiles. And it's, even if you don't want to use these tiles specifically, you can use these as examples for how to make use of the API in the best way. The repo is called 2D Extras, and it was made by the 2D team at Unity. I'll just leave this up in case anyone needs a picture of the link, but it's also on this slide. In this GIF, I'm using tiles from a different palette to just paint some decoration onto the scene. And there's also, it's going to be hard to see, but I also use a custom brush called the random brush, so I can paint random patches of grass without having to swap out my sprite every time. And the random brush and random tile are also available in that 2D Extras repo that I've mentioned. So I'm going to show you a quick demo where I use tile maps so you can see all of the different features in context of each other. I'll just swap over quickly. Okay. So this is a project I've got called Penny Pixel. You can download this project and play around with it if you Google Intro to 2D World Building with Tile Maps. It's a tutorial put out by Unity where you can step through and create your own tile map scene, or you can simply download this and play around if you want to. So let's just have a run around and so you can see what's going on. So I've got some animated tiles. I've got decoration that I can go in front of and behind. I've got these gems. These gems are using a prefab brush, which is also available in that 2D Extras repo. And this was so that I can paint these collectibles on and not have to individually place them into the positions I want. I can use it just like a normal brush and paint 3D objects. So I can run down here, but I get stuck. So let me fix this. Let's paint some tiles onto this scene. So if I go to Window, 2D, Tile Palette, you can have a look at the Tile Palette window. Oh, that's a spoiler. You can see that one later. Okay, so here I've got my grass palette, and this is how a typical tile palette like this would be set up. In this actual scene here, I'd use the rule tile to paint everything so that it would join together really nicely. So I'm just going to use that now so that it looks nice for the sake of a demo, like otherwise it will look a bit weird. But as you can see, like it just wants to automatically join everything. So I'm just going to make this a little bit easier for me to jump on so that I don't get stuck again. Let's leave that little window. And I can switch over my active tile map, and let's get rid of that piece of grass that's in the front there. I can swap over to the eraser over here. Just get rid of that. So let's go back into play mode. Now, as you can see, the collision was already taken care of. I didn't need to set up any more box colliders or anything like that. This was taken care of by the Tilemap Collider, and I'll talk about that a bit more in a minute. So tile maps are all different game objects. Let me open up the inspector. We've got our ground. Oh, I'm just going to make use of this focus on part in the scene view here so you can see exactly which tile map I'm focusing on for this section of the talk. So we've got the ground, and that's all of the platforms that I was running around on. We've got our background decoration. That's our trees and bushes that we were running around in front of. The foreground was the rocks and other bushes. And we've got the waterfalls. So as you may have noticed, when I was running around in play mode, the waterfalls were actually animated. Every tile map comes with this animation frame rate property, and you can change how fast you want your tiles to animate. So if I just go back in here, let's have a play around. Oh, I'm not going to be able to see the inspector if it's like that, am I? Right. So right now it's 5. It's kind of gentle-ish waterfall. Let's put this up to like 60. And it's pretty rapid. So yeah, I don't know, maybe this is the type of game you're going for. Personally, I think that's a bit too fast. 15 seems kind of smooth. I think I'll leave it there. Obviously, I'm in play mode, so this won't save, but you get the idea. So as well as the different tile maps, let me just turn off this focus, we've also got the grid. I like to think of the grid as being the thing that is holding all of these tile maps in place. Now, if I go back over to the tile palette, I'll talk about these buttons at the top. So we've got this, the arrow to select. You can select an area of the grid. You can use this within the tile palette and within the scene view. So I can select here, and then maybe I would want to paint with that one. Or I can select here. We've got moving around for whatever reason. Like if you want to edit the tile palette, for example, you could move these. Zoom out a little bit. We've got the brush. You saw me painting with the brush earlier. Oh my gosh. Sorry, having the accessibility thing on made me confused and I zoomed all the way out. Okay. So I've got the brush. But as I'm not using rule tiles now, so that looks kind of weird. I can paint with a big area at once by dragging. I can select a particular tile and then paint with that kind. So let's choose something like this edged piece. Can erase all of that. And we've also got this fill. So while I'm talking about the fill, I'll just point out that you can go into your Unity preferences And in the 2D section of the preferences, there's this show flood fill preview. You might want to turn this off if you're working with a really large tile map because it will slow things down if you have the preview on. And this is a talk that talks about performance, so I thought I'd let you know about how that's going to work. So I could turn this off. And now with the flood fill, I won't see a preview, but I can actually still do it. So collision, we saw that I was able to run around really quickly and not have to change the colliders. Tilemaps have Tilemap Colliders that you can add as a component, and there's also this used by composite checkbox. So if you're using a Tilemap Collider in combination with the composite collider, you see how these are all different squares here for the different tiles. If I tick used by composite, that just now, well, let's turn off that background so it's easier to see. You can now see that the collider's going all the way around rather than on the individual tiles. So while I'm here, I'm going to show you some isometric tiles as well, just so you can see the different art styles that are available with the 2D tile maps. So isometric tile maps work much the same as the square ones, but as you can see, you get a very different art style coming across. And of course, that depends on how you author your assets, but I think it's really nice to see how different these can look, and you're not necessarily restricted by just having squares. We've got this little cute point and click game here with Unity Chan. We can turn on and off the ground. We can turn on and off the buildings. I could move these buildings around if I wanted to. So yeah, that was just some 2D tile maps and the isometric version as well as the square ones. Oh, before I leave this demo, I want to show you when you're looking at individual tile assets, you can set the collider per tile. So maybe you've got some tiles that are slightly different shapes and you want them to be based on the sprite, you can do that. Or if it's something that you're not that concerned about, maybe it's like a type of background tile, you can change that to grid and it will set the collider to go all the way around in just a square. And again, that would have implications on your performance if you have lots of sprite ones or just grids. So I think that's all I'm doing for the demo. Let's go back here. To recap what I've just covered, just in case anyone is still unsure about what I just did, let's cover this in terms of Bob Ross. So the grid is a bit like the easel of your painting. It's the thing that's holding everything in place. The tile map is the canvas which you're painting onto. The tile palette is the paint palette. The tiles are the blobs of paint. The brush is the brush that you're painting with, and you are Bob Ross. I'm so glad you laughed. I was really worried no one would care. Okay, so I've covered tile maps. You should know what they are, hopefully. But why should you use them? What problems do tile maps even solve? First, your workflow. As you saw in that demo, it was really quick and easy for me to make levels. I could just paint and the colliders are taken care of. It's also great for artists. I didn't use any code in that demo, and you could see, like, with my painting, I mean, it's not like I was doing anything really artistic, but you could see how easy it was for me to get things laid out into the scene. And third, performance. The way that tile maps work under the hood means that it's more performant than using lots of sprites. And this talk covers how tile maps compare to sprites and why that matters when you're making a mobile game. But what is performance? Often when people hear the word performance, their brain jumps to frame rate. And while frame rate is a way to measure performance, it's not the only thing we want to be looking at. Frame rate is a target of how many milliseconds you have to perform actions in each frame. So if your target FPS is 60, that means you have 16 milliseconds per frame to do all of your rendering and updating and changing the state of the game. So performance is a more general umbrella term that's used to talk about memory usage, CPU usage, GPU usage, and frame rate is just one way to measure those things. Before I talk more about tile maps, let's cover mobile and why you should care about optimizing for mobile. It's often said not to do premature optimization, and only worry about optimizing when you're faced with a performance problem. However, this is really only the case if we're talking about code. When we're talking about assets and your data, we definitely should be thinking about performance from the beginning. When you're optimizing your code at the end of the project, you are typically changing how you work with the data and assets to improve performance. But if your data is fundamentally non-performant, however, there is little you can do in the code to solve this. Changing all of your data and assets in this late stage of the project could be impossible if you're trying to meet deadlines and get your project out on time. So why should you optimize for mobile? Mobile isn't just one thing. For example, the newer iPhones, the iPhone 10 and onwards, those phones are beasts. They are essentially small computers. But different markets have different popular devices, and very low-end Android phones are actually the most popular smartphones, especially in Southeast Asia and India. Also, app stores have their own size limits, and you need to be thinking about your consumers' phones as well. Like, you don't want to take up all of their hard drive space. You're not the only thing that they're using on their phone. And RAM. A good rule of thumb when we're talking about RAM is to use about 1/3 of the available RAM on your lowest end device. So if you're targeting low-end Android as your worst device, that maybe they have 1 gig of RAM. So you'd want to be using about 350 megabytes as an absolute top limit so that you're not taking up all of their phone's RAM. You want to think about battery usage as well, so that your game isn't just good for your consumers and it's not going to run down your players' phones, but it's also better for the environment. Like if your phone needs to be recharged after every play, it's not the most green thing. And while we're talking about profiling, it's recommended to profile on your worst available iOS device because Xcode's free profiling tools are really very good. So of course, test across all your different devices, but if you're just benchmarking performance, do that on your worst iOS device and make use of those free profiling tools. So now we're talking about Tilemap's performance. And again, when I say performance, this is CPU, GPU, and memory, RAM. One of the things that's great about Tilemaps is you have fewer game objects in your scene. As you'll know if you've worked on 2D games before, you end up with lots of sprites in the scene, and all of them are separate game objects. Each component on a sprite game object, so your transform, your sprite renderer, takes up memory. Other components, like colliders, have overhead, including CPU time to handle their update calls. And having singular components manage this results in less overhead by handling its own data structures compared to having multiple data structures across memory. So we're talking about one tilemap renderer for the whole tilemap and all of its tiles versus multiple sprite renderers on multiple sprites. And of course, if you've got fewer game objects, you've got a neater hierarchy, so that's going to improve your workflow. You're not going to be scrolling through your hierarchy trying to find what you're looking for. Everything's going to be confined into those small tilemaps. So I mentioned in the demo about the Tilemap Collider. I've just got another GIF here to remind everyone. Having lots of components on lots of game objects results in lots of overhead. I said that in the last slide. And then when we're using the Tilemap Collider combined with the Composite Collider, that will not only get rid of having lots of colliders and lots of sprites, but this is a huge production time saver as well. There's no need to rebuild all these complex collision shapes every time you make a change. The Composite Collider takes care of that for you. I also mentioned in the demo how you can have the sprite colliders or the grid colliders, depending on the shape of your tiles. As you should be able to see in the corner of this GIF, the corners of the platforms are just rounded. They're not exactly square. And that's just because it's combining the grid collider type with the sprite collider type. Scene size. Tilemaps have an effect on your scene size. Loading in Unity is a two-stage process. You're reading the data from disk, and then you're deserializing that data into Unity objects. Reading from disk is the thing that often takes up the most time in your game, and that happens especially on Android. If you've got more objects, you've got more things to serialize. Deserialization is the process of transforming data from one format to another. It usually means converting data from a format where it's been saved on disk or transferred over a network into data that you can use. So in layman's terms, that's restoring data and objects from a saved state. You might already do this without realizing if you save the state of your game into an XML file or a JSON, for example. You might have your players save the game, and it writes out the saved state of that game into a file, and then when they load up the game, it reads from that file. When you're loading it up, that's deserializing it. So Unity does deserialization internally whenever it loads a scene file, in the editor and at runtime. It takes those saved files and turns them into Unity objects. So I wanted to dig under the hood of Tilemaps to look at the performance. So to do that, I compared a scene using Tilemaps to a scene using sprites. The scene that I used to do this was from Robbie Swifthand by Pixel Rain. This was actually used in the Unite Berlin training day. They used Tilemaps in their game, and I thought I would recreate it using sprites to have a more realistic game to do this profiling on. So the scene itself has 4 different Tilemaps, as well as you can see from this slide, a bunch of different decorations and lighting and UI and so on. So it's quite a robust scene. It's not just some tiles in an empty scene. So like I said, I recreated this using sprites, but I didn't use any third-party Tilemap solutions to place the sprites. I simply was placing the sprites directly into the scene, and the sprites were atlased using the Unity Sprite Atlas system. To really show what I'm saying, these are screenshots from 2 serialized scene files. On the right is a section from a serialized tilemap, and on the left is a sprite game object, and that sprite game object has a transform and a sprite renderer component. I haven't shown the full serialization because it's very long, but hopefully you can get the idea from these 2 screenshots. So I'll talk more about the differences in the renderers in a minute, but you can see how the tilemap, can I see my cursor on the slide? Yeah, up here. So the tilemap up the top here sets the rules for all of the tiles, including like the type of tiles that it's going to be using. And then each of the tiles underneath it are simply stating their position and other things like that. Whereas the sprite serialization is doing so much work just for one sprite. So to reiterate, on this slide, there are 4 tiles being shown and 1 sprite, and it's not even the full sprite. If you want to view your own scenes as a text file, you can go into your editor settings and turn on the asset serialization mode to force text, and then open the .unity scene file in a text editor. Like I said, the files were too long to show you in screenshots on slides, and you probably can't even see what's going on. It's not that important to the talk, but in the scene file using sprites, there were 370,000 lines. Again, this was Robbie Swifthand that I recreated using sprites instead of tilemaps, 370,000 lines. The original file for the game using tilemaps was 30,000 lines. So this is a huge difference. All I changed was switching out from tilemaps to sprites. And remember, when you load your scene, every line must be loaded from disk and deserialized. So you can see just from looking at these numbers that the tilemap scene is quicker to load because it's quicker to deserialize. We're not just talking about runtime performance here either. This also impacts the size of the on disk of your built game, and therefore your workflow when you're developing. So much time is spent sometimes checking out of repos or like cloning, pulling, all of that stuff because of large files in your project. So again, Robbie Swifthand, when I recreated it with sprites, was 10 megabytes. The original scene file size with Tilemaps was 831 kilobytes. So we've got a smaller project size, a smaller repo size, meaning faster iteration times and nicer workflow in general. Renderer overhead. Each renderer has its own CPU overhead, which includes time for culling, preparation, and cleanup for rendering. Each sprite in a scene has a sprite renderer component. Having more renderers means that more CPU time is spent on these tasks compared to having singular components, i.e. one tilemap renderer compared to lots of sprite renderers. If you have more than one camera in your scene, having more renderers will increase the cost of culling. So when I say culling, in layman's terms, it's really working out what you don't want to be showing on the screen, like in the view of the camera. there is a per renderer, per camera cost to culling. Every camera has to perform culling checks on every renderer in the scene. So if you have a multi-camera setup for your game, using Tilemaps will really help you reduce that cost. Batching. Again, in layman's terms, batching is getting all of the objects that are similar and drawing them all at once, kind of. The Tilemap renderer batches the geometry of the sprites in the tilemap into groups based on their position. This means that the Tilemap renderer sends less meshes with more geometry to the render pipeline compared to the sprite renderer, which sends more meshes with less geometry. You may have seen batches before if you've looked at the stats panel in your game view. It might be quite hard to see, but in this slide it's got 7 batches and it's saved 22 by using batching. But you can also use the frame debug window to show you why things aren't batching. I'm not going to go into loads of detail about the frame debug window, but it's a useful thing to look at if you want to learn about batching in the context of your own game. So for example, in this screenshot, this draw call wasn't being batched with the previous one because the objects are affected by different forward lights. And there are multiple reasons why something might not be batched, for example, the forward lights, or if it's using a different material. So in terms of batches, that scene that I recreated using lots of sprites had 1,930 batches. For those of you who are familiar with performance in games, you will be able to see from this number that this was barely running on a mobile phone. So the original game using Tilemaps was 157 batches. And again, this scene was a realistic scene which had lots of lighting and decoration and UI. But for those interested, I tested this on a very simple scene as well. So this was a scene where it was one sprite, which was laid out 160 by 160, just the same sprite, and that had 5 batches. And when I used that same sprite as a tile and laid it out as a 160 by 160 tile map, it had 2 batches. So even on this small scale, there's a difference, and of course that scales up. Frame times. When I'm talking about frame times, that's how long it's taking for rendering and other things in the game. And like I mentioned earlier on, if you want 60 frames per second, you want 16 milliseconds each frame. When I was profiling on an iPhone 7, that was my worst available iOS device, I had 244 milliseconds frame time with the scene using sprites. The original scene using Tilemaps was 13 milliseconds. So this is under my threshold, and I was getting more than 60 frames per second. And again, I checked this on this simple scene that I mentioned before, where I had 160 by 160 sprites, all of the same type, and it was 35 milliseconds. So this was only just getting about 30 frames per second, even on a very simple scene using sprites. And the Tilemaps version of that, where it was 160 by 160 tiles of the same kind, was 1 millisecond. So even on this scale, where it's a very simple scene, it's occurring, and as you could see, that was scaling up as well. This was also using the Robbie Swift hand test project, where I recreated it with sprites. The RAM usage was 1.1 gigabytes with sprites. And like I said at the beginning, like your very low-end Android mobile phones won't have this amount of RAM available to them. And on this iPhone 7, it was very hot, and it was not working very well. But when I was using the original scene with the Tilemaps, it was 21 megabytes of RAM. Sorry, there's lots of like acronyms that I've got to all, you know how it is. Anyway, it was 21 megabytes. So this was having no problem running when it was Tilemaps. And again, this was measured on an iPhone 7. So I just wanted to put up a further reading slide if you wanted to dig more into this. These are some links and articles that I either spoke about in this talk or I used for my research in this talk. Feel free to take a picture of this if you want to do some more reading. We've got the 2D Extras repo that I mentioned at the beginning. We've also got Intro to 2D World Building with Tilemap. That's that tutorial I spoke about where you can download Penny Pixel and go and dig into it. And optimizing graphics rendering in Unity games is a really great Unity article that will teach you about batching and set pass calls and just like really help you understand what's going on with the rendering in your game. And it also shows you how to go through the profiler window and really dig into what problems your game might be having. So in conclusion, it's a nicer workflow for your developers and your artists using Tilemaps. we've got the performance benefits that I mentioned. There's quicker load times, smaller file sizes, better runtime performance. Thank you. So just a reminder about the Unity 2D challenge, where you can win cash prizes for showcasing your 2D skills. The link is on the screen. That's connect.unity.com/challenges/2D challenge. Make something cool with Tilemaps. Submit it to the challenge. Are there any questions? I have some time to take some questions if anyone has any. Okay, it doesn't look like it.
Sorry, for you.
Oh, sorry.
Hi.
Hi.
So started playing around with the hex tile map. I had some questions about, it's a top-down game, about navigation, being able to address where those tiles are. In a grid game, it's pretty easy because it's, by two, but with the hex, it's really hard to figure out where the tile maps are. So how do you do that? And can you use something like NavMesh with that?
So 2D NavMesh isn't currently available. But if for your specific game, I think it would be nice if I could, have you got the game with you today?
I don't, I'm sorry.
Okay. Well, I'd like to chat to you in more detail about this, so we could sit outside afterwards in the Q&A section and go back and forth about it if you like.
That would be wonderful, thank you.
Okay, thank you. Are there any other questions? Hi.
I'm just curious, what are the pixel sizes of some of the tile maps in some of the examples that you show, or if there's kind of a standard?
Okay, so that's a good question. I'll actually go into Unity so I can show you more about that. So a lot of the ones I was using were 64 by 64, for example. And in your texture import settings, let me find a good one that I can use for this. Penny pixel. Oh, that's actually penny. Oh, I'll show you here, for example, anyway. So we've got this pixels per unit over here. And it basically, as long as you set this to whatever your size is of the tiles and the sprites, then the tile map will work with it. Because this by default is 100, so when you're importing your sprites and your tiles, just make sure that you've set this to whatever you have authored your sprites to be. Does that answer your question? Okay. Anyone else? Okay. Oh, are you going?
Yep.
Okay.
Okay, so I was trying to get more functionality out of my tiles, and I was considering using the prefab brush, to paint all the tiles.
Yeah.
So imagine if, these scenes that, like what you're working on, all the tiles were prefab brushes, or were, prefabs. Is that going to negate a lot of the performance gains that you talked about, because now you have kind of a game object per tile?
Yes, so I haven't profiled that specific scenario exactly, but it's a good point, because obviously you've got the tile map, which is sorting out the positions of all the tiles, but if your tiles are game objects, in fact, I can actually show you in a scene. So you know how the tile map was one game object? In the case where I've got the gems, these are prefab brushes. Each gem is showing as a separate game object. It doesn't go onto the tile map, so you won't have the same performance benefits if you were just simply using 2D. Does that answer your question?
Yeah, it does.
Okay.
Thanks.
So, to sort of jump on what was said previously, why don't you guys make a tile that allows you to basically get the gains from your conventional tile, not a prefab tile, just for the rendering purposes, and then also allows you to have a game object behind it?
I mean, it's a good idea. I'd really like to look into that myself, actually. So yeah, that's a good idea. And we've got some people from the 2D team in the room, so they have heard your request as well. Hi.
That little 3D isometric scene that you just had up.
Yeah.
Just curious what the tiles for that look like.
Oh, the tile. Oh, sure. Yeah. So this is the isometric scene. They're actually 2D sprites, but they are just authored to look 3D. So we've got the tile palette set up over here. These are from Kenny Assets, who, if anyone's familiar with him, he does lots of free 2D and 3D assets. So for example, I can just grab these in a brush and just paint them over here. and you can set up the sorting to make sure that everything's going to be lining up correctly. It's pretty neat. It's nice to get like a 3D style, but still using the 2D renderers and getting those benefits. Hi.
Hi. Can a tile map be turned into a prefab?
It can, and I've tested this out with the new improved prefabs workflow. There are some implications where you need to prefab the grid as well, things like that. But yes, basically it can also be a prefab, and I encourage you to play around with it and see what you can get. I had some fun making some procedural dungeons using Tilemaps as prefabs and using the variants as well. It was good fun. Okay, I think I'm going to call it then. Thank you for all your questions. That was really good.